Good afternoon, everyone. This is the Armchair Forecaster, and I decided to do something a little bit different today. Instead of typing out my forecast discussion and posting it on the blog or on Twitter, decided to do more of a live stream and show you my forecasting process in real time as we forecast for tomorrow, which would be Friday, March 14th, otherwise fondly known as Pi Day. So definitely a big severe weather event coming out for the next couple days for parts of the Midwest and the Southeast. And so far, I've really been trying to avoid looking at SPC outlooks, mostly because I've been wanting to try to not bias myself by looking at their forecasts and trying just to mimic them. What this is going to try to be is my own independent attempt at my own convective outlook. So with that, let's go ahead and get started and jump right into it. Going to shoot for about 30 to 45-ish minutes here. But let's just start with the observations. So what have we got going on? So right now we're looking at mid-level water vapor imagery and over the CONUS. This is from GOES 16, and there's a couple of features we can already pick out. The first one is this upper low moving across northern Alabama into northern Georgia. This was the system that tracked across the southern plains yesterday into Arkansas and gave us a line of storms across eastern Texas, a couple of hail events across central Arkansas, but otherwise kind of turned out to be a dud of an event. But right now, this thing is moving off to the east coast. You can see a couple of cells trying to develop there on the southern flank of it. So for today, this feature is really not going to play too much of a role, except the big question is there a really robust surface low with this? Maybe it has a cold front draping across towards the Gulf. Is that going to push our moisture out of the way ahead of the more higher amplitude, the bigger wave that's coming out across Southern California right now? Looking back off towards the west, we can see this really highly amplified upper level low or upper level trough. Moving on to Southern California right now, and actually let's go ahead and switch over to CONUS radar imagery. There's that line of storms that came through last night across eastern Texas, died off, a couple of hail events near the vorticity maximum with that upper low moving across to northern Alabama, northern Georgia. But like I said, let's move our attention back off to Southern California. Here's all the precipitation with that upper level low that's coming out into Southern California right now. Got a couple of special marine warnings out, some flash flooding issues. But this is the system, going back to water vapor imagery, this is the system that's going to be bringing us our big severe weather event for the next 2 days across parts of the Midwest and the Southeast. So where's this thing going to go? What does the moisture return look like ahead of it? These are the main questions that we should be able to start answering today. We're sitting about 24 hours before the start of the event should begin, and so there should be some things that are really obviously apparent. So moisture return. What kind of moisture do we have in the lower Mississippi Valley that could return up into the Midwest? How expansive will that moisture return or the warm sector be? Upper level winds. You can kind of get a sense just by looking at water vapor imagery how fast the upper level winds are moving, or the upper level clouds moving, that there should be some pretty decent winds aloft. So I don't think wind shear is going to be too much of an issue. But forcing for ascent, you kind of want to be in this Goldilocks zone of not too strong but not too weak, so that you get discrete supercells. If you want a big tornado outbreak, that is, you're looking for that Goldilocks zone. If it's too strong, you may grow upscale too quickly into a squall line. If it's too weak, you might not get storms at all. Then the next question is, how about instability? We're sitting at mid-March right now. This is a little bit early to really get a really good elevated mixed layer developed across the Southwest and New Mexico and advecting out over into the plains and even towards the Mississippi Valley. We're still a little bit early for that. You would really expect an EML to start developing more into May and April and May, and really as you head into the summer months. So the question is, what do the lapse rates look like right now across New Mexico, Texas, Oklahoma, and where are they going to go over the next 24 hours? Will they overlap with our moisture as it returns back to the north to give us our maximum moisture underneath really good lapse rates, which will maximize our buoyancy, give us a lot of fuel for thunderstorms? So these are the kind of the questions that we're going to be answering, and really what we're going to be shooting for is where's the best overlap of all these ingredients, and that's where we'll probably be putting our highest risk probabilities. And then of course towards the end we'll take a look at some convective allowing guidance, or convection allowing guidance, namely the HER, maybe a few others, to get a sense of what kind of storm mode do we most likely expect, and how confident are we on our convective coverage, and that will ultimately be the deciding factors for our probability lines. And so let's dive into it. Let's start with the moisture return. So we're going to jump to surface observations. This was valid as of, that'd be 17 UTC, so just about 30 minutes ago. So it should be pretty good. So the first things that we're going to do is take a look at dew points across Oklahoma, Arkansas, Mississippi, Louisiana, Texas. Zooming in, just eyeballing. We'll just do some contours right here. We'll do some light blue for our 50-degree isodrosotherm. We'll start out down here. Looks like we got mid to low 50s across eastern Texas. Kind of comes back over here into Oklahoma. And let's see. Okay, so we're getting low 50s dew points up into southern Illinois. That's not too bad. 55, 57, southern Illinois. Looks like we come in through here. And let's just draw. There's some 40s. There's our 50s, 45. That looks like a 48, so we'll go down south of it. Cut up. Alright, so there's our 50-degree isodrosotherm. Again, you kind of have to match your moisture content with the season that you're in. So we're sitting in early spring right now, so 50-degree isodrosotherm could be a good delineator of where your warm sector is. If we're sitting in like mid-June, you kind of want to look for like low to mid-60s. But for early to mid-March, yeah, 50 might do it. Obviously, it just depends on what the temperature profile aloft looks like, which we'll get into in a bit. Let's jump to our 60-degree isodrosotherm. So we got some low 60s down here. Kind of cuts across. Here's a 64, 61, so there might be, but we were kind of surrounded by these upper 50s. So yeah, there might be a true 60-degree isodrosotherm somewhere like this. Yeah, and we got some low 60s. Eastern Mississippi. And then we come up, got a 64, 59. And yeah, it looks like it just kind of trails off into the Gulf like that. All right, so there's our 60-degree isodrosotherm. And now for the big time moisture, 70 Fahrenheit. Looks like there's a 73, a 70. It's overall not great. I don't know quite what to do with this 70. I'm not quite sure if it goes up like this, so for right now I'll just kind of leave it. But yeah, so there's our rough dew point analysis as of roughly 17Z, 24 hours prior to the event. All right, now let's start looking for some surface features. Can we identify, at this point, the wave is still pretty far back out to the west. It's over California, so we wouldn't necessarily expect to see a robust surface low starting to develop quite just yet or somewhere over the high plains. But there might be some good details that we can find out. So let's just try to identify where some surface lows, surface highs might be. That could definitely help us out. I'm actually going to start down here in the Tennessee Valley into the southeast, because we do have the upper trough moving across. So maybe there's some kind of front. Just glancing at this, I don't see an obvious cold front that's wiping out the moisture. Our isodrosotherms kind of confirm that. But let's just take a quick glance here, see what we can identify. So we're looking at 10-11, 10-10. Generally speaking, it looks like a lot of our lower pressure, there's not a really obvious surface low back over the southern Appalachians. If we go back to our water vapor imagery, it looks like that circulation, yeah, it's really broad. It's not very well defined. And so we're kind of seeing that at the surface. It's kind of a weak upper level wave, and so at the surface you're not really seeing much of a surface manifestation, that's actually pretty good. That actually might help us out, because then we're not scouring out the moisture down to the Gulf Coast. We're actually keeping it inland. And looking back over Mississippi, western Alabama, this is return flow. This is trajectories that are coming from the western Gulf up through the Mississippi Valley. So this is the trajectory you want to see if you want good moisture return. It looks like we have a bit of maybe a warm front. Actually, I'm going to draw that right through here. Get a slightly bigger marker. It's it might take too much time to do a proper temperature analysis, so I'm just going to eyeball this, judging by the wind barbs. But notice that we have southerlies coming up through southern Illinois, then we switch to easterly across central and northern Illinois. This pattern implies that we have some kind of a warm frontal feature, maybe right through here. Something kind of like that. So we have some kind of warm frontal feature. It kind of becomes more diffuse as you move towards the Great Plains. but you go from upper 60s, low 70s to upper 50s. So yeah, it still kind of goes up through here, but not quite as well defined. We'll note that we go from 70 to 55 once you get into eastern South Dakota. This thing might, yeah, it's really tough, but it might just go just like that. And we could tell that we've got some kind of broad circulation going across northern Montana, easterly flow across southern Canada, northerly flow coming into northwest Montana, more westerly, more southerly. So you get some sense of broad cyclonic circulation right here. Looking at the surface pressure field, you go from 990, 950, some 950s, 970s up here. So yeah, surface low developing across northern Montana. Looks like, let's see if there's any other features we can try to identify. I'm gonna get this brown color out. It's all pretty diffuse. I will point out that you do have some westerly flow here across the Texas Panhandle, more southerly across central Oklahoma. So that kind of implies there's some kind of feature right through here. Maybe it kind of goes down like that, but it's really not well defined at all. Looking back up across the high plains, yeah, again, you have this different air mass between this downslope flow regime across eastern Colorado and the more southerly return flow over the plains, which again, not terribly well defined. Maybe something kind of like that, but that's, yeah, it's not a perfect guess, but you kind of get some sense that there's some kind of maybe a boundary trying to develop there between the downslope flow regime and the more southerly return flow that's starting to develop as this low up here begins to deepen. Okay, so there's a really, really rough surface analysis, not my typical detail, but for the sake of our purposes right now, that should work. Let's look back off across the west, and we're actually going to switch to 500 millibar heights. So I'm going to turn off the radar here, turn off the surface observations, turn on our 500 millibar heights, and we see in this, this is a rapid analysis, probably valid at 17Z, so about 45 minutes ago from now. I'm going to draw on some of the bigger features in yellow. Maybe this orangish color, actually, slightly bigger pen. So yeah, the big feature, of course, is going to be this upper level trough that's really situated right along the west coast at this point. And then we do have some embedded jet streaks, the most prominent of which looks to be this just under 100 knot jet, 80 to 100 knot jet coming into Southern California, Baja California. Then we do have weaker jet streaks up here, one that's coming across southeast Canada, and then this weaker jet streak across the northern Gulf that's associated with our upper low over the Tennessee Valley right now and the southeast states. But again, this guy really should be translating off to the east coast over the next 24 hours. I don't think it's going to be too much of an issue. All focus will be on this upper trough right here. Just from a QG standpoint, you have to ask yourself, where do we expect this thing to go? It's beginning to get a negatively tilt orientation to it, so that trough axis points from the northwest down to the southeast. Upper level jet is really entering the base of the trough right now. If this upper jet was more situated back up on the west side of this upper trough, you can make a QG argument that this trough would continue to dig down to the south and maybe take a trajectory from, the California coast all the way down just through the Four Corners region and then eject out into like maybe the southern to central plains. But instead what we're seeing is that this jet streak is already entering the base of the trough. That implies that it might not be pushing to the south quite as much as what we'd expect previously. It might begin more of an east to northeast translation over the next 24 hours. And so roughly speaking, let's draw in, use a black arrow. The question is, where do we expect the base of this trough to go and the jet streak to go? Probably off just like that over the next 24 hours. So that should place a lot of the forcing for ascent over Nebraska, Iowa, northern Missouri into maybe parts of Illinois. And I can't imagine that it's gonna All right, so that's at 500 millibars. So let's take a step down. We're going to go down to 700 millibars. At this level, we're really going to be looking for a couple things. The first is temperature advection. What does our temperature advection look like? This will influence how our upper level field is going to change in terms of, is the upper level ridge and trough going to amplify, maybe de-amplify over the next 24 hours? What we want to see is really strong cold advection at the base of this trough. So this jet streak and this dashed line right here kind of denote where our upper level features of 500 millibars are. So do we see really strong cold advection at 700 millibars underneath it? The answer is yeah, a little bit. It's not great, but it's not terrible either. We do have some cross isothermal flow at 700 millibars, really just off the north coast of Baja California, right in through here. And so that implies that we're going to see 500 millibar heights falling over the next 24 hours back over this way. So that kind of implies, well, maybe actually this thing won't progress off to the east quite as fast as if we had weaker cold air advection, because there's going to be a tendency for the heights to fall back off slightly to the west of where the trough axis is right now. Let's drop down to 850 millibars. But here we see that the best cold advection is actually moving on shore across Southern California right now. We're having cold advection, yeah, Southern and Central California, all the way down just off the coast of Baja California. And so this kind of implies that we would actually be seeing heights falling on shore over the next 24 hours. So there's kind of this competing factor depending on where the maximum cold air advection is. But in general, I think the overall signal is, yeah, this upper level trough will probably amplify over the next 24 hours given this cold air advection. It's not overly strong, but it's not terribly weak either. Note also at 850 millibars, we have this broad warm frontal zone at 850. This matches with what we are seeing at the surface. So this surface boundary is just the manifestation of the more broad warm frontal zone that we're seeing over the northern plains into southern Canada and parts of the Midwest. So what does that imply for the next 24 hours? Well, that tells us that we should be seeing heights rising, upper level ridging, and that might actually help maintain, because if you imagine that we're going to be rising our heights across here, that actually might help maintain that negatively tilt orientation of the upper level trough as it moves out into the plains over the next 24 hours. What does that tell us about our forcing for ascent? It might be more focused, because you get this negatively tilted trough that has really strong vorticity advection right out ahead of it, really right along this arrow here. And so forcing for ascent might actually be pretty strong across, central to northern plains into the upper Mississippi Valley by this time tomorrow. With that, you might anticipate really strong surface low development. So maybe this low begins to develop and migrate down south along this zone of warm air advection, and where we'll have really strong forcing for ascent on the synoptic scale. So maybe the surface low starts to develop down to the southeast over the next 24 hours. What would that do to our surface moisture return? Well, if we have our low deepening and moving out towards like South Dakota, Minnesota, that should induce really strong southerly flow and bring this moisture up even more, possibly up into the lower Mississippi Valley, or I'm sorry, the upper Mississippi Valley, into parts of eastern Iowa. So those, just looking at the observations, that's kind of my guess as to what might happen. Moving down to 925, really seeing similar things, broad warm frontal zone across the Midwest into the northern plains. We're starting to get a sense of maybe some better moisture, some deeper moisture return. Notice the green dashed lines. These are our isodrosotherms at 925. Just following the trajectories, looks like they're going to be coming up into Mississippi, Alabama over the next 24 hours. But again, if we see a deepening surface low up in this region, I would expect those winds to turn more southerly, bring that moisture straight up the Mississippi Valley. All right, finally, we're going to be looking at lapse rates. So that's the other kind of big question. Like I mentioned, we're kind of early in the year for a really good EML, but do we have any lapse rates that are already out there? Man, take a look at this. We have 7 to 7.5 across much of the high plains into the southern plains. And so some of the 12Z soundings that I want to go ahead and look at are maybe Amarillo, Midland, Dallas-Fort Worth. We'll take a look at Norman, because this is the lapse rate plume that should be moving off to the northeast over the next 24 hours and give us a good overlap of this moisture with these lapse rates, maximizing buoyancy. So let's go ahead and do that. Let's go ahead and take a look at our 12Z soundings. So here's Amarillo. Notice that we do have this this segment or layer of steep lapse rates really from about 600 to about 400 millibars. Okay, so that's not too bad, but lapse rates down low really between 850 to really 600 millibars. Not terribly great. Looking at Midland, much of the same. Dodge City, a little bit steeper, between 850 to about 600 millibars. Very dry though. Take a look at North Platte. That's more what we're after, is a really good deep mix layer. It is really pretty warm. Those temperatures at the warm nose are about 15 Celsius. That's pretty darn warm. You don't want to see it quite that warm for a really good severe threat, 'cause that might mean there's too much capping. So lapse rates, maybe not great, but not terrible either for this time of year. The other thing to consider is if we do have a rather large scale trough moving through that's inducing a lot of ascent, you will get a lot of deep layer ascent, deep layer cooling of the lapse rates, and a overall increase in instability, which might lead to better buoyancy. So that's something to consider, is that what we're seeing right now might not be what we get to this time tomorrow because of that ascent induced by the approaching wave. So that'd be something to watch for as we look at 12Z soundings tomorrow morning. We'll see what our moisture return looks like. So we were seeing those, go back to our surface chart, those 60s all the way up into southern Mississippi and much of Louisiana. So we can look at the Lake Charles, New Orleans, Jackson soundings and see what the moisture content looks like. Lake Charles, that's decent. You got some pretty good moisture up through about 900 millibars. Looking at New Orleans, about the same thing. I noticed these lapse rates aren't terrible. That's about almost 8 Kelvin per kilometer through 700 to 500 millibars. Look at Jackson. Similar thing, actually. These aren't terrible lapse rates. And I guess the question is, will they stay in place for the next couple of days? That'll kind of be the thing to watch. So we are getting some good lapse rates. We're starting to get the moisture. Dew points at 12Z at Jackson were only about 55, 56. Now we're sitting at low to mid 60s across southern Mississippi. So moisture return has been ongoing since this morning, which is excellent. That's really what you want to see if you want a good severe weather outbreak. Looking at Birmingham, they were in the mid 50s. Now they are sitting at maybe upper 50s, low 60s, might be moving into there. Yeah, I'd say probably low 60s at this point. So that's good. So we do have this nice reservoir of moisture already in place across Louisiana, Mississippi, Alabama. We have some decent lapse rates back off to the west that should be moving. I'll switch over to this view. Should be moving off to the northeast, and we do have this plume of lapse rates already in place. So the question is, can these be maintained? We're kind of getting some sense that forcing percent might be greatest across the upper Mississippi Valley. So where's that Goldilocks zone between really good moisture, really good lapse rates, and just enough forcing percent? It might be in between. So maybe looking at the confluence of the Mississippi and Ohio rivers, southeast Missouri, southern Illinois, into northeast Arkansas, western Tennessee. That's my first guess, but we'll have to take a look. So right now, that's my idea of what I'm going to be looking for as we look towards the numerical models. So we'll take a look at those, and then we'll actually start drawing some forecast lines here in a second. So let's hop over. I am starting with the NAM right here, but we'll take a look at a few others. All right, so let's step through this. So this is at about 18C, so this is pretty close to where we're at right now. This seems to match really well with the analysis we were just looking at, with the upper level jet moving into Southern California. This wave is moving across the Tennessee Valley. This might be a little bit slow, but it's not too far off. And so let's see how this progresses over the next 24 hours. That wave moves almost due east. It's actually more easterly than I anticipated. I thought it would be more to the northeast. So by 21Z tomorrow, that upper level jet streak is, really punching into southwest Missouri, upper level low right over eastern Kansas. I would anticipate that means the surface low somewhere over Illinois or Iowa, maybe eastern Nebraska, somewhere within this left exit region where you have really good diffluence aloft, really strong ascent within the left exit region of the jet, and ahead of the main upper level trough. So that would be my guess, is a surface low somewhere up here based off the NAM. But let's jump down to the surface and see what it's suggesting. And we'll take, we'll start off with temperature first. So that's at 21Z Friday. A little bit further west than I anticipated, so it's back off across south central to central Nebraska. Well, let's see what else it's got. So it's got southerly winds all along lower Mississippi Valley up to the lower Ohio Valley. Really strong southwesterly flow. So somewhere here, I'd expect some kind of, looks like you go from mid 70s, then you get into the 60s. So this is kind of implying some kind of a dry line feature across much of Arkansas into maybe western Louisiana. Let's take a look at dew point temperature at the same time. Yeah, so there's our dry line setup. Step back and just loop through this. See how it evolves. So this right here is actually a convective signal. What it's doing is the models are actually initiating convection and wiping out that moisture. So that's kind of a clue already. Remember, we were saying that we expect the strongest forcing for ascent out ahead of the wave across this region, the upper Mississippi Valley. So far, based off the NAM, that kind of tracks. Looks like trailing dry line across much of Arkansas. That could be very interesting. And notice that the 60-degree isotherm noses into southern, almost central Illinois. Let's take a step back. So here's 18Z Friday. Let's go to 18Z Thursday. So here's where we're sitting right now. Just to get a sense, the NAM typically does have a bias to be a little bit too moist, a little bit too cool. And so are we seeing that moist bias in place right now? So just looking at the 60-degree isotherm, which is this blue layer or blue color right through here, it's got 60 degrees almost up to Memphis, Tennessee. Let's go back and look at our analysis. Close. It's a little bit close. Maybe not quite as expansive. Let's turn off lapse rates there. So our 60-degree isotherm doesn't quite get up into northern Mississippi. It looks like dew points there are in the mid to upper 50s. The NAM is suggesting that right now they should be at 62. So yeah, the NAM's a little bit too aggressive with the moisture return as of right now, so that's something to keep into account. That moisture return might not be quite as good 24 hours from now as what the NAM is depicting. And it's saying that, yeah, a little over 24 hours from now, you're getting 60-degree dew points, up into southern Illinois. I think we'll see it in northeast Arkansas, western Tennessee. That seems really pretty reasonable to me. But just how far north to go, yeah, that's kind of a question mark. Anything north of southern Illinois, I think, is kind of a question mark to see how far that moisture actually gets, but something to definitely keep in mind. All right, so that's the NAM solution. Let's go ahead and jump over to the wrap. So we'll take a step back. Usually the wrap handles things quite a bit better. So we'll jump back to 18Z Thursday. So it's still maybe a little bit too aggressive with the moisture return as of right now. It's also showing low 60s northern Mississippi when we're actually sitting at the mid to upper 50s. Let's take a step forward in time, go through the next 24 hours. That moisture plume returning back up through the Mississippi Valley, and then by 18Z Friday, showing quite a bit of mixing, and that's something to keep in mind about the wrap. The wrap and the herd tend to overmix just slightly, and so you actually wouldn't see or expect to see quite as good moisture return compared to the NAM, which tends to undermix and keep clouds locked in far too long. So maybe in this case I would actually lean more towards the wrap, because I think that mixing that we're seeing as those dew points go from the low 60s across western Tennessee, they drop down to the 50s, that's indicative of diurnal mixing. That makes a lot of sense to me. So then we go to 21Z Friday. Here comes that dry line. Doesn't quite make too much progress. The strongest forcing still seems to be across Iowa into Missouri. That's where we see the best dry line push. One thing we can look at is wind speeds at 700 millibars to see where we expect, or where should we expect the best dry line push. Well, it should be right ahead of the mid-level wave or mid-level jet. And sometimes you can use 700 millibar winds as a proxy for, that can sometimes be right at the top of the boundary layer. And so you have to ask yourself, okay, if we're mixing down 700 millibar winds, that might lead us to expect where the dry line is going to be bulging out the best, where we see better forcing for ascent, which seems, again, to be northern Missouri, southern Iowa by tomorrow afternoon. Something else to consider, let's jump up to 500 millibars. very similar evolution to the NAM, which isn't terribly surprising. But notice that our dry line orientation was arcing from the northwest down to the southeast and then back down to the south. So if you're sitting up here, western Illinois, southeast Iowa, notice how your deep layer winds are going to be off that dry line. That kind of implies you're going to be getting more discrete convection, at least initially. And this is where it kind of gets messy because we have really strong forcing for ascent, but we also have deep layer flow that's off the initiating boundary. Flow off the boundary implies better chances for discrete convection, but stronger forcing for ascent implies rapid upscale growth because you're just lifting a bunch of parcels all at once. So it's kind of a question mark as to what kind of storm mode we can expect. Maybe discrete initially, followed by quick upscale growth. And depending on what storm mode you expect, can kind of imply what kind of hazards you should expect as well. So kind of some question marks across Iowa, Illinois, parts of Missouri. And then further down to the south, that dry line, that boundary kind of arced back to the southwest. Our deep layer flow is more along that boundary. That kind of tells you, maybe not quite as good of a chance for discrete convection, but your forcing for ascent is weaker, which would favor discrete storms. So again, kind of this question mark of what kind of storm mode we're going to get all along the boundary. It's not super clear cut. Maybe the best chance is going to be across east central Missouri into southern Illinois. Remember, we expect, it wasn't unreasonable to expect 60 degrees to reach up to southeast Missouri, southern Illinois. Maybe this is that Goldilocks zone right here where we could expect the best chance for discrete convection with really good buoyancy. Maybe that'll give us our best shot at some more widespread severe weather. Let's jump over to some of our convective parameters, look at surface-based CAPE. So this is suggesting that about 7 p.m. tomorrow could be uncapped across northeast Arkansas, southeast Missouri, looking at about 1,000 joules per kilogram, maybe 1,500. So decent buoyancy for this time of year. Definitely nothing earth-shattering like the 4,000 joules per kilogram we could see during the summertime. But for mid-March, that's really not too bad. Up here across Iowa, I keep forgetting the states, buoyancy is only about 500 to 1,000, which is kind of on the lower end, but that's sufficient, especially given that we're going to have really strong forcing for ascent, maybe better flow, which can compensate for the lack of buoyancy. So there's still definitely a severe threat. But if we were seeing SB CAPE values of 1,000 to 2,000, that would definitely be ringing a bunch of alarm bells. And then further down south towards western Mississippi, you're looking at higher CAPE values. That makes sense. We have better moisture down there. Looking at closer to 1,500 joules per kilogram, maybe getting up to close to 2,000 by the late evening into the overnight hours, as that moisture return continues to just pump north with the deepening surface low to the north. So definitely a lot of things to consider. I think we're seeing a really clear axis of where the severe threat's going to be. I would say from the eastern South Dakota, eastern Nebraska, maybe limited across central Mississippi and then back west. And then I would include really all the way down towards the Texarkana region as possible, danger zones, depending on, just look at, that's 23Z, looking at like the Hot Springs, Arkansas area. Let's just take a sounding from there. It's going to take a second to load up. There we go. So yeah, lapse rates aren't great. This warm nose right here at about, 6 to 650 millibars. Not great. That can cause some issues because your parcels are trying to go up, but then they start to run into this warm, dry layer. Acceleration's not great. Entrainment increases, but then they can keep going. But looking at the hodograph, that's really not a terrible hodograph at all. Your surface to 1 kilometer SRH above 150, so that's definitely within the range for tornadoes. Overall STP is kind of low, but that's probably because effective inflow SRH only 200. You'd like to see it above 250. MLK below 1,000. Ideally, you'd like to see it above 1,500 for really high STP values. So this kind of qualifies as a low CAPE high shear environment, but yeah, definitely worth watching. Let's find some more soundings here. Let's take a look. Let's take a look at western Illinois in the afternoon, heading into the early evening hours. Very strong winds. Notice your winds in the lowest kilometers are between 50 to 60 knots. Your storm motions, your mean storm motions are 63 knots. So if anyone who's thinking about chasing this stuff, I mean, good luck. You're going to be driving at interstate speeds on rural county roads trying to keep up with the storms. Yeah, just good luck. That seems like a really tough chase day. But looking at the overall environment, this looks like it's probably convectively contaminated. So I'm going to take a step back, find a different time, maybe find a different sounding. We'll look at parts of Missouri. Actually, we'll look at the capped environment too. We'll take a look at both, because this also looks like, that's kind of what I expected. Where we're seeing the lower SB sin is probably where the models are showing convection, so we're getting these convectively contaminated soundings. That's probably a bit more realistic to what the pre-storm environment looks like. Again, not great buoyancy, but probably sufficient. ML Cape between 500 to 1,000, but again, really strong flow in the lowest few layers. 0 to 1 kilometer SRH above 250. That's definitely within tornado range, and definitely within like wind damage concern range. I mean, even for the Midwest and parts of the plains where there aren't quite as many trees to knock down, that'll still do a lot of damage. So definitely wind. I think wind right now is really sticking out to me, followed by tornado. Hail, I never rule out hail, but just given the so-so buoyancy and so-so lapse rates, it's kind of like maybe hail's a secondary or even tertiary threat. And then let's look at the overnight period. So we'll go to like 5Z, look at northwest Mississippi, where we're getting the better buoyancy as that moisture return continues. The question here is going to be, man, we're displaced a little bit from the better flow aloft, but still really good flow. I mean, your 500 millibar winds, 65 knots, 850 winds, 50 knots. That's still really good. Notice that our analogs, our SARS analogs, we're getting some supercell and some very, very large hail analogs popping up. So that raises some alarms. STP, STP between 2 to 3. So yeah, our better tornado environment might actually be overnight into parts of like Mississippi, eastern Arkansas, southwest Tennessee, which again, that's kind of what we were thinking, somewhere to the south and west of that the surface low. That's where our Goldilocks zone is probably going to be, and then it just becomes a question of storm mode. So let's look at that. Let's finally jump to some cams and start to look at storm mode a little bit. And we'll start with, there we go, simulated reflectivity. Oh, I don't want to spoil it. Let's jump back. All right, we're looking at the 12Z runs. So we'll take a look at the more recent runs, although the 12Z probably goes out. We'll see if the 18Z won't be in yet. So let's take a look here. So this has storm initiation across just east of the Kansas City Metro around 22Z tomorrow. Cells go up, and notice that they're going up really quickly into a line. So this is that storm mode question that we're talking about. Will we get discrete cells, or will we see rapid upscale growth into a line, which would imply a better wind threat? And given those wind profiles, if we get a line, man, you're looking at a really good wind threat potential here. And that's kind of what the HRRR is suggesting. Granted, the HRRR was incredibly incorrect over the last 48 hours with that little wave that came across eastern Texas that's now over the Tennessee Valley. It did terribly with that one, so you always got to take this with a grain of salt. But notice, yeah, by 1Z, we've got a line. It's kind of hinting at these embedded UH swaths. Question mark for everyone is, are these embedded supercells, or is it trying to pick up on QLCS mesovortices? I would argue probably embedded supercells, just given the resolution of the HRRR at 3 kilometers. Probably can't resolve QLCS mesovortices too well. So yeah, I'd probably guess embedded supercells. And those track across western Illinois, gets into the Chicago Metro around 6Z, so around that midnight time frame, maybe a little bit later, 1 a.m. But then down to the south, not as much of a UH signal with this activity. Let's move our domain. Yeah, we'll go southeast. So remember, our sounding suggested that like 5, 6Z, we have a really good environment across northern Mississippi, northwest Mississippi. But HRRR's kind of suggesting almost lackluster potential, not much of a UH signal there. And then we get into more of a Saturday. Well, actually, we got to consider we go through 12Z Saturday. So yeah, this is actually something to consider. Is that the herd showing maybe early morning potential across parts of Alabama. So that's something to consider as well. Again, it should be a similar environment to what we saw across northwest Mississippi, just displaced to the east as that whole pattern is just shifting east. So yeah, so that's interesting. Let's try to get a ensemble picture. So by this point, the href should be in. We'll take a quick look at that, and then we're going to start drawing some lines. So we'll go to the SPC webpage. Again, I'm going to try to avoid looking at any contours. That anchoring bias is very strong. All right, let's jump to storm attributes. And we're going to look at 4-hour max reflectivity with MU cape about 50. So here we go. So interestingly enough, the HER runs we were just looking at said that CI was east of the Kansas City Metro. There's a couple members here. It looks like the NAM-NEST members are showing CI to the west of the Kansas City Metro. So that's something. If you're in Kansas City, you're going to be on the border, but you might not be totally out of the woods. And as we go through the afternoon, very strong convective signal across Missouri into Iowa. That kind of meshes well with what we're seeing from the HER. More isolated, streaky signal across the Mississippi River Valley, across western Mississippi. Again, that makes sense. Weaker forcing for ascent with southern extent. Forcing for ascent with southern extent. And then we have the secondary surge late overnight into early Saturday morning across parts of southwest Alabama. Let's go check out 4-hour max UH. I'm also going to turn off the cities here. All right, so here we go, about 20Z. So interestingly enough, not a really great UH signal until well into the overnight hours across parts of Illinois into northern Mississippi. Kind of same deal. There we go, that's what I was looking for. Alright, so here we go into the event. So remember, the NAM-NEST had stuff developing west of Kansas City, but UH is really pretty weak until you get to about 23Z across parts of Iowa, and these are all the FV3 members, which have a tendency to, be really aggressive when it comes to supercellular convection and spinning up mesocyclones. But definitely seeing that the best signals across eastern Missouri into central Illinois. But man, the FV3 just seems to be dominating the signal. Let's try to take that out. So now we can see where the rest of the members, they're really hitting on that St. Louis area around 0 to 5, 6Z. So yeah, definitely not a super clear-cut forecast. I wouldn't rule out the tornado threat down here. I'm not seeing that much of a convective signal to make me think really high probs at this point. Obviously, the best signals across Iowa, Missouri, Illinois. So we're going to go with higher probs across here. Right now, leaning towards wind, but just given the flow fields, embedded QLCS circulations will be an issue more than likely, just given the SRH in that environment. So I think mainly wind, followed closely by tornado. Hail's on the lower end. If anything, hail might be better down to the south, where you have maybe a slightly better chance for a more discrete mode. But it's tough. I'll definitely have some hail probs in there. A couple other things to look at really quick. Let's just look at 24-hour max wind. Oh, that's a really strong wind signal. I mean, yeah, I think I'll be bringing my wind props all the way back, maybe even to northeast Kansas. That's a really, really good wind signal, especially across parts of Iowa into Illinois. So that's very good. Let's see what our probability for 50 knots is. All right, so there's where our highest chance, based off the href members, where our highest chance of getting severe wind gusts might be. All right, so let's start drawing some lines here. and knock this out. So, we actually got a couple of severe warnings down here, southeast Alabama. That cell right there actually has some decent reflectivity associated with it, but that is for today. That's today's problem. We are worried about tomorrow. I'm actually going to turn that off just so we are not tempted to look at it. And really, I could turn off radar imagery altogether because we're really just focusing on drawing those forecast lines. So like I said, let's start with the wind. That seems to be the biggest issue. My first guess, man, I always have to question if I want to include. Let's change map modes here, make this a little bit more clear. The Kansas City area, do I want to include it? Are they going to see a severe threat? If the NAM nest is right, maybe. I mean, just given the flow, I would think that any convection could produce some kind of wind damage. But confidence isn't super high, so maybe 5% is just fine, and maybe I'll go. Alright, so maybe I'll go just like this, now that we're not frozen anymore. Zoom out a bit. And this is just my really, really rough guess. It's always tough to know how far east to go with these things. But then I want to capture the early morning stuff across Alabama. So this is going to end up being a pretty big area. Maybe something like that is my really, really rough first guess. And then we'll go through and refine it. How far south to bring it? Big question mark. I don't know if I want to include New Orleans, Lake Charles, this area, or just keep them just north. Yeah, maybe I'll do something kind of like that, but keep parts of the Gulf Coast in. Again, keep in mind this is our 5% line. So we're not really suggesting a super high threat, just some threat. There we go. Let's zoom back out just a little bit more. All right, so let's go with our higher probs, go with our 15. So this is, the way to think about this is where would you expect potentially for there to be a watch? There was a really good wind signal back up here across, parts of Iowa. I mean, this is our main corridor right through here, so maybe I'll just start there. Maybe something just like that. And then again, let's go back. Well, actually, let's go back and take a look at the her again. Yeah, let's take a look at the Midwest section. Go to the 12Z run. Look at surface gust potential. So there we go. There's our signal. So that's starting off with a pretty good severe gust signal, northern Missouri, almost all the way to the Chicago area. So yeah, right through there is going to be our corridor. So that's what we're going to highlight with our highest probs. So I'm actually going to expand my 15 just a bit. Maybe include the Milwaukee area, line it up with the lakeshore. And I'll even expand this one out just a little bit. Keep in mind, you always want to trim to the water areas because there aren't any trees, or there's some sensors, so there's some buoys, but those get usually reported as marine wind gusts, not severe thunderstorm wind gusts. So I try to avoid going over the water too much. We saw that convective, or that severe wind signal starting northern Missouri, kind of translating up this way. So always want to build in some kind of a buffer room for that. So we'll do that as soon as we unfreeze here in a second. There we go. Just make this a little bit more broad. And again, the question is, how far south do I want to go with this? That's something we're going to have to think about here in a second, but for the meantime, Let's toss in a 30 because that's a pretty good signal. Just the overall strength of this system makes me pretty confident we'll see some pretty good winds. Something kind of like that. All right, so there's our rough first guess at wind. There's still some questions with this. I mean, there's still questions of like how far south do we take it down into? Do we go all the way to Memphis? Do we bring it all the way down into Mississippi? Yeah, just thinking about it. One thing to consider is you have to think about what are the impact thresholds for different parts of the country. And so parts of, Mississippi, Alabama, Georgia, their impact thresholds are a lot lower than, say, rural Kansas, where there's not quite as many trees or structures to knock down. Parts of the Southeast are a little bit more vulnerable. There's a lot of studies to show that. So I actually might bring that 15 down. Feeling pretty good that we'll get some kind of wind down here. But again, not super confident on exactly how far or what kind of shape this should take. So for example, Birmingham, they were kind of looking to be more of a early morning threat, which would make it inherently more uncertain. Nashville, same thing. Don't want to include them. It's not super clear. Let's go back, see, can we get anything out of what the herd might suggest, especially timing-wise. So Nashville's looking at 9Z, just given the strength of the forcing percent, given the flow, could definitely see some kind of a severe threat with that. So yeah, I'd say we keep them in the slight, in the 15 wind. And maybe just give ourselves a bit more cushion on this eastern edge. That tends to be another area where we tend to underdo it on the eastern edge of these systems, especially the strongly forced ones. They tend to go a little bit further than we initially expect. But I do recognize I'm running the risk of getting a pretty large false alarm penalty if this doesn't pan out. But I think I like this so far. Okay, so let's zoom back out. Zoom out one more time. There we go. Okay, so there's our wind threat so far. So far, I like it. Again, there are a lot of questions about, do I want to bring this back down to the southwest? Parts of the Texarkana area might be under the gun. Let's go back, change our domain again, look at southern Great Plains, rewind the clock. So Hurley is suggesting no real CI along that dry line across Arkansas. Maybe not till the late evening hours, well into the overnight. So we might have some potential for some false alarm across Louisiana and parts of Arkansas. So that's something to consider. Maybe I'll trim this just a bit to reflect that uncertainty. And I won't bring it into Texas. We'll keep it kind of like this. Include more of western Alabama where we have that better signal. Yeah, hopefully this captures that general idea a little bit better. So I think from here, the best option that we're going to have is to just simply copy our wind line as a tornado line. So I'm going to use this copy tool, grab my wind, 5%, tornado 2. That seems good. So if we switch over to our tornado, there's our 2% tornado line. I think that looks pretty good. And let's go ahead. Whoop, there we go. Underlay our wind with it. So there's our wind lines in blue, our tornado line in green. And let's just see, let's just really quickly put in some more lines here. I almost just want to do a straight copy. So grab my wind 15, make it a tornado 5, put it in there. Take my wind 30, make it a tornado 10, toss it in. Again, the idea here, more QLCS tornadoes versus more of a supercellular tornado threat. But down here, less confidence, but maybe a better potential for supercell tornadoes. So you might have the stronger tornadoes down here across Mississippi, Alabama, but maybe more numerous tornadoes up here across Missouri, Iowa, Illinois. And again, based off our current scoring system, we're going for number of LSRs and the concentration of LSRs versus intensity. So we kind of have to take that intensity aspect out of this forecast for right now. But otherwise, yeah, I'd be messaging the potential for stronger tornadoes given those STP values we saw in the soundings down here across Mississippi, Alabama. All right, so now that just leaves us with our hail. So again, here are our wind lines. Man, I'm really tempted to just do a straight copy. Whoop, go wind 5, copy it as a hail 5. And then the question becomes, do I have any other adjustments I can make off this? So for one, once we get really into this section of the outlook area, we're expecting this to be a squall line, so your hail potential should be a lot lower. So maybe we'll just bring it south. We'll kind of delimit it like this, but keep in mind down here there's that potential for more supercellular convection, which would have a better hail threat. So maybe we wouldn't limit it quite as much. Like, I don't really know if the Chicago area is really going to have much of a hail threat. And we'll just keep this confined, maybe just like that. Kind of like that idea. Yeah, I can't really justify moving that western edge. This area might be a bit of a false alarm, but again, lower probabilities, so I can live with it for right now. And then, do I want to go any higher? I'm not sure. I don't think so. I think I'm happy with that right now. So there's our forecast. Just to recap, let's just run through this. So general expectations for tomorrow. Really strong upper level wave coming out. The best forcing for ascent, best flow overall. Expecting to be across parts of the Mississippi, upper Mississippi Valley into the Midwest. We're putting our highest probabilities across, from Des Moines down to St. Louis, not quite to Chicago, but expecting our best wind threat across here due to the combination of really strong forcing for ascent that should favor more of a linear mode, really good cross line, cross boundary, cross line flow, which should help propagate the system. Really high wind damage potential, so I really think we're gonna have our best wind threat across here. Tornado threat will probably be secondary, but definitely there. And then down here across parts of the lower Mississippi Valley, Mississippi, Alabama, more scattered to isolated threat, but potentially higher impact, more intense, just given the better buoyancy, but still really good deep layer wind shear and low level helicity. Going with our tornado threat, again, highlighting up here for the potential for embedded QLCS circulations, not necessarily really good supercells, although there was that embedded supercell signal across parts of southeast into eastern Missouri. So actually, now I'm thinking about it, maybe we'll just drag our 10 tornado down just a little bit, capture the Missouri boot hill, but not, just barely glance Arkansas. I like that idea. And then finally, hail. Overall, maybe not a big hail day. Definitely could see some hail though, especially down here. But again, I'm not super confident on the coverage. There wasn't a really strong signal. Overall, lapse rates aren't great. Buoyancy isn't great for big hail. The shear's there, but the other ingredients may or may not be. So it's kind of a bigger question mark. So right now, that's our forecast. Final notes here. I'll probably be updating this in the morning as we get more data. But again, if you disagree, feel free to put in another forecast. I'd be eager to see what you get, and we'll see how the scores come out. And so until next time, it's been the Armchair Forecaster, and we'll talk to you later.